So there are two closely related effects that are related to a delay line. One is called a flange. And what a flange is the effect of combing out frequencies in a continuously changing frequency range. The flange effect is created by adding two identical audio signals with one slightly delayed relative to the other. So there's our delay line concept. Usually on the order of milliseconds. So it's a very, very, might be 10 milliseconds or 5 milliseconds, right? It's a very, very slight delay. And additionally, the effect involves continuously changing the amount of delay, causing the combed frequencies to sweep back and forth through the audible spectrum. So what we do is, if I have some delay time, it might constantly change between, let's 5 and 10 milliseconds, sort of going back and forth. And actually I can use typically an LFO to control this. So if you use something like a sine wave to control the rate of the delay time to go between, let's say, if this low was 5 milliseconds and the high was 10 milliseconds, right? Then it would continuously change the rate of the delay time. And then I can also combine this with some feedback as well. In the days of analog equipment like tape reels, flange was created mechanically by playing two identical copies of an audio signal simultaneously and initially in sync on two separate tape decks. So here's a typical tape deck. And then a finger was pressed slightly against the edge. So I would place my finger right here, right along the edge in here. And this is called the flange on a tape. And what you would do is lightly touch one of the tape reels, slowing it down in RPMs just slightly. This delay in one of the copies of the identical waveforms being summed resulted in the combing out of the corresponding fundamental frequencies and its harmonics. Flanging by means of phase shifting can result in the combing of non-harmonic frequencies such that the space between combed frequencies is not regular. The amount of feedback in flanging can also be varied. So basically what I can do is I can adjust the depth of my LFO and the amount, which will adjust the amount of the delay time. And then also, so the depth will control, let's say, what range, right? And then the rate of the LFO will control the how fast or slow it's changing, right? So if I have a very slow waveform, I might have very slow. It's sort of like imagining sort of adding a little bit of pressure to the flange and then releasing it ever so slightly versus maybe doing that more quickly. And so that's the rate. And then the depth would be sort of the amount of the flange. And so you'll often see this option when we use a flange effect. And then I can also control the amount of feedback as well. Flanging with a relatively long delay between copies of audio is sometimes referred to as chorusing. So I can think of a chorus effect. So you'll often find flange and chorus as well as delays. And these are all separate effects that are related to one another. In chorus, the pitch of the added voices is typically modulated by an LFO. And a chorus effect is essentially achieved by taking an audio signal and mixing it with one or more delayed pitch modulated copies of itself. So we typically have much longer waveforms, and we can often change the waveform. And if we change it, if it's sort of always changing, so if I change it with something like noise, then it creates a really kind of ever-changing effect. And then the other thing is I'm going to keep the depth of this very low, and the delay time is very, very low. So I'm getting ever so slight sort of pitch variance over time, which makes it sound like there's a chorus in essence, a chorus of singers or chorus of voices. So now you know the basics of what a delay line is, a flange, which is related to the delay line, and also a chorus effect, which is related to a type of flange. I've loaded a couple clips into Ableton to demo both a flange and chorus effect. This first clip is just a clarinet. Here it is without any effects. And then this is an audio clip of some percussion. Okay, so both those are without effects at this point. I'm going to go back to the first track. And so let's take a look at a flange here. And let's first just listen to it. So I've activated this flange. And again, to find the flange effect, I'm going to go under Audio Effects, under the Ableton browser, and I can scroll down to Flanger. And if I just drag this into a track, it just drops it into there as a default. Or I can also then, here's some preset settings for the flanger. So I've just used the default setting right here. I'm going to adjust the wet dry mix a little bit here. So we have some buttons and knobs here I'm going to go over very quickly. But let's first listen to this. Okay, so you can hear some little interesting effects happening through there. Wet dry mix is pretty self-explanatory, as we went over this in a delay line, and it's going to be the same for the flanger. So again, wet is all just flanged effect. Dry would mean only the original sound, so with no effect. So we'll leave it somewhere in the middle. Sometimes we want to have just the effect. Again, this is part of an artistic decision you can make. There is a high pass filter here, which will cut low frequencies, let high frequencies pass. So I will adjust this as this plays. So you can hear these little frequencies in the background kind of coming in and out as I adjust the high pass frequency. This area here in the middle is where we control the delay time and the feedback. Delay time is the horizontal axis and feedback is the vertical axis. So I can adjust them either with this or with this. And there's a little polarity button here, which you can adjust to see what the audio result will be if you like it better or not. And I can also just click and drag this, and you'll notice it adjusts both of these. Our limits are a 7 millisecond delay and 0.99% feedback, right? So I suspect 1 would have been 100% feedback. So this is like 99% feedback. And in terms of our lowest settings, we can get 0.1 millisecond and no feedback. So I'll just play this, and I'm just going to slide it from this setting all the way up to here and then back. Okay, I'm going to set it to the most extreme setting here so we can hear some of these other things that we can do to the sound over here. We can affect the attack time for the effect as well as the release. So this can sometimes be handy if you want to have sort of the release of the effect go on a little bit longer after the sound has stopped. That's cool, as well as obviously the attack. And then the envelope just adjusts sort of the size of the envelope that the effect takes shape. And then we have this section over here called LFO, S and H. S and H meaning sample and hold. And so I'm going to adjust, I can adjust the amount of the effect that's going on in terms of in terms of the flange effect. And then also, so in a way this is the depth. And then we can also adjust the shape of the waveform in terms of the LFO that's affecting this flange. So remember, this is not a true flange where we're actually putting our finger on the flange of a tape, but we're trying to mimic that through a low frequency oscillator that's adjusting the delay time over time using one of these different waveforms. And sometimes you can get some pretty cool effects by adjusting between sine wave, particularly a pulse wave, and then noise. I find that it's very subtle sine and triangle, and then sawtooth waveforms can be interesting as well. And so I would encourage you to try all of these and see what you get. We'll try a couple right now. So I'll play the sound. So you can hear in this case, the depth is very slight, very subtle. And if I increase this amount to 100%, it's going to go crazy. And you can see as I adjusted the rate, this is the rate of this LFO, in this case 1.7 hertz. So I can have a very long, slow waveform. So pretty cool effect there. Obviously, this is very extreme. We're sort of used to hearing the flange more down here. So that's very subtle. And sometimes we want that. We just want some sort of subtle changes. And sometimes we want something really extreme up here. I'm going to keep it to extreme so you really hear the difference between some of these things. I'm going to change the waveform now. If you want to sync this rate, so you can hear it's kind of going back and forth between these two pulses, a high and a low. If I sync this to my metronome, now what I can do is based on my tempo. So let me make my tempo, I'll keep it at 120 for now. And if I adjust the metronome, so that's pretty cool if you actually want the sort of a beating effect that matches whatever tempo you're in. You can use this button here to sync it with your BPM. I'll put it back to hertz here. And then finally, I want you to hear what noise sounds like because this is pretty cool. So I just adjusted the delay time and feedback just slightly. So flange is very cool. There's some very cool effects we can create with this. Here's some more subtle ones, so here's some other presets. So you can see that's using noise. It's a little more subtle than the last sound I used there. Let's move on to chorus. So here's a chorus effect. Let's listen to that. So you can see it sounds all of a sudden like there are many clarinets. And so similar to the flange, I have a high pass filter here, so I can adjust this to adjust the quality of the tone here. So this way I'm letting very few frequencies come through, mostly some of the upper partials, versus then if I open this up, now many more of the sort of pitch shifted tones that are coming through here through this delay and rate will hear it. And so again, I have the this is my delay time here. So I have it anywhere from 0.01 milliseconds all the way to 20 milliseconds. So that's quite an extreme range. Let's hear what that sounds like. And then I also have, so similar to the flange, I have an amount, which is my vertical axis. So again, this is like depth. And then the rate is, this is the rate of the my LFO. So I've got everything from 0.03 hertz to, looks like 10 hertz. And we can listen to what that sounds like. There's a polarity button here. You can hear what that does. So that just flips our polarity of our waveform. And then we also have a feedback. Right now feedback is turned off. Let me turn some feedback on here. So that's really extreme. It's probably not how chorus is typically used, though it can be a really interesting creative tool. We're probably mostly hearing things like this Resonorous preset. Or this more subtle one here. Okay, and then let me go to this track here just so we hear some of these. So here's a flange with a percussive effect. So here's just percussion. You can really hear that LFO sort of moving in and out. Let me increase the rate. And there's unaffected. Let me add some chorus to this. All right. So you can hear sometimes, depending on the sound, if we have a very, like with this clarinet tone, because it's such a pure tone, as we were adding some other wave, some modulation to the delays that are going through this, we really notice those effects. Sometimes they're less noticeable through something like these percussive sounds, and actually what we're doing is we're actually hearing with chorus and flange some pitch actually being added to it through these LFOs that are modulating or changing these delay times and then creating these different sort of bending frequencies. So I encourage you to explore using delays, flange, and chorus on every and all of your audio and MIDI tracks to see if you can get your sounds to grow and expand and change over time.